Stress-strain diagram indicates the relationship between stress and strain. Various parameters, which includes mechanical properties, are defined associating with the diagram. Here, we briefly introduce important parameters determined in stress-strain diagram. Proportional limit is the limit of the range in which stress and strain are proportional. The point elastic limit, which is neighboring the proportional limit, is generally a little above the proportional limit. The elastic limit means the limit of elasticity. After exceeding the elastic limit, permanent deformation occurs. Even after the removal of loading, strain remains, and the material does not return to the original position. Next is about tensile strength. When a material is stretched, pulled, the stress which is on the vertical axis in the stress-strain diagram reaches at its highest. The stress here is called tensile strength. The tensile strength is defined as the limit of stress that the material withstands. Next is about yield stress. When a material reaches yield point and starts plastic deformation. As you see in the stress-strain diagram, the load or stress rapidly drops a little. Yield stress clearly appears in the stress-strain diagram of mild steel, which has a carbon content of less than 0.3%. On the curve of the relationship between stress and strain, the upper point at which the curve shows linear rises and falls is commonly called upper yield point. This lower point, the fracturing region, in which plastic deforms instably, is called lower yield point. Together, they are called yield point. Now, you should be familiar with proportional limit, elastic limit, yield stress, and tensile strength. You should be noted that many materials do not have clear yield point in the stress-strain diagram of hard steels. We cannot define yield point of a material that do not generate clear yield point. So, we define a parameter called proof stress for the materials that do not have clear yield stress. The proof stress is obtained by drawing a line parallel to the line within original elastic range. You should draw a line originated from the point of strain 0.2% parallel to the line in the elastic region. Then, the stress at the point of intersection with the curve of the stress-strain diagram is generally defined as the proof stress.